Hey guys, welcome back. If you notice, I may be in the exact same spot as the last video you saw me in, where I took apart this Toyota starter. But while I have the starter apart, I wanted to talk to you guys about the starter solenoid a little bit more. Not so much the contacts, but a lot of people don't know how the starter solenoid actually engages, and that there are multiple parts to that starter solenoid. So inside this starter solenoid, we have a hold-in coil and a pull-in coil. Now there's two separate coils of wire inside this solenoid. And as you can guess it, the pull-in pulls the solenoid in and the hold-in keeps it held in. Well, why don't we just use one of those solenoids? Why don't we just have a pull-in coil and it keeps this starter pulled in the whole time? Well, because it takes a lot more energy to pull that solenoid in as it does to keep it held. You know, when you're picking something up, it takes a lot of energy to get it up off the ground. But once you have it, you know, held up here and resting on your belly, it's not that hard to hold it there for quite a while. So the same thing's going on inside the starter solenoid. Plus, once that solenoid engages, we want to use all the available amperage that we have from that battery to get the engine spinning over. If we're wasting energy holding that coil in by using a pull-in coil, then we won't have quite the available amperage to spin the starter over. Probably don't need to draw in rainbow colors. So I'm going to jump onto the laptop and we're going to draw just the solenoid. We're going to ignore the starter motor for now. So what our solenoid has is on this Toyota. I'll do the terminals on the side. I know you're 90% of the other vehicles out there, the terminals are going to be on the back, but for the drawing, it's easier on the side. So this is going to be a B plus terminal. Yeah, there'll be little threads on there. This is where our battery cable is going to hook to from the battery. And then it's going to go inside the solenoid down to a starter contact. And then on the other side, we have another contact, and it comes up here, and there is another stud. I know I'm an expert at drawing.
You're an expert at English.
Expert at English. And there's our output from the solenoid. But then we also have this other terminal, and this is going to be our S plus terminal. There's different names for it. It's our start terminal. That is the terminal that comes over here, and I'll try to attempt to draw a key. It comes over to our key, and then from the key, it goes over here, running out of space. We're just going to draw ourselves a battery. So B plus. Cable goes over here to ground. This is B minus. And then we have another cable coming over here to our B plus terminal. Now, since this is a Nip and Denso starter, we have a long rod connected to a cylinder, and there's a spring on the rod. We have our starter contacts and a little dome. And I'm going to write some blue here. That's our contact, and here's our contact. So that's how our starter contact works, is this plunger gets pulled down against those contacts. But how does it get pulled down in there? Well, we talked about it. I'm going to switch to green just so we have some contrasting colors here, make it look a little Christmassy. We have this coming down here. Now it doesn't touch the contact, but bear with me. And there is going to be, actually might not go that far here. There is going to be a big winding of coils in here, and then once we get done winding around and around, it's going to come and it's going to tie on to the output contact of our starting solenoid. Now, you probably expected this wire to be connected to ground. Well, there isn't a connection to ground on the pull-in coil, at least not all of the time. When we first turn the key to crank, how much voltage do we have at the starter motor terminal? Our contacts have not closed yet. So in the brief period of time when we turn that vehicle to crank, now I'll pull up a waveform. We measured, it was like 30 milliseconds or 20 milliseconds of time before these contacts touch. During that time, this pull-in coil is grounded through the starter motor. So this source right here is going to be at 0 volts at this time. Once the contacts touch, once that solenoid moves in, I'm running out of colors here very quickly. Once our contacts touch and I get power to go from the battery all the way to the B+ terminal, all the way through this contact, through that contact, and then down into the starter, what is my voltage potential at this point now? Well, now we're going to have the same as our B+. Now, to make it simple, I'm just going to put 12 volts here. It's going to drop a little bit as that starter starts spinning up and our voltage and amperage curves from our starter show up. But we'll say we have 12 volts. Well, if I have 12 volts at the starter solenoid from my key, and I have 12 volts where the green wire connects to that other contact, how much voltage difference do I have? It's going to be 0, right? 12 minus 12, 0 volts. At 0 volts of difference, I don't have any current passing through it. So at this point, my starter would disengage, right? Well, we need another color. There's actually 2 wires that come off of our starter solenoid. Now I'm drawing this one in a little smaller wire because it's only the hold-in coil. And it comes down here, and we only have a few windings. And then what does it do is it ties into the side of the starter contact, or the solenoid, and that is a ground potential. So we always have 0 volts there. So in turn, when we turn that key to run, or to crank, we actually have 2 solenoids working at the same time until that contact fully engages. Once the contact engages, the hold-in coil is the only one doing the work, and it pulls less than half of what the pull-in coil does. We might be able to check that on this starter since we have it out. We'll see what the voltage or the amperage difference between those 2 solenoids is. So I hope that made sense on how the pull-in and the hold-in coils work. When we turn that key to the crank position, we have power going to both coils. They are both grounded. One's grounded to the case and one is grounded to the starter motor. Now the starter motor is not going to start spinning over because that's not enough power. Even if it did, it would be at a slow speed. It's not going to crank the engine over. Once the solenoid fully contacts, which means I used all that energy to pull that solenoid over, this plunger, once it makes contact, I lose my ground for the pull-in coil. My amperage drops way down, but I'm able to maintain keeping that solenoid pulled in, and it keeps the starter spinning. The additional amperage that I was using, or current that I was using to pull this thing in, gets delivered now to the starter to crank it over. I'm not wasting it. I hope that made sense. Let's actually measure it real quick, and we'll wrap it up. So what I'm going to do is connect my starter button to the starter solenoid, energize wire there. Let's connect the ground of my jump pack to the starter case. The other side of my solenoid is going to get hooked up to the positive side of this jump pack, maybe. Now we're not going to hear anything happen. You know, if I stick the plunger in there, we might, get some action here. Make sure that nothing's going to get torn up. And then I have one more jumper lead. I don't actually want this starter to spin over, so I'm not going to connect the starter motor lead. I'd probably be safer if I put all the contacts and stuff back in here, but we'll try to get this, somewhat okay in here. So my yellow lead, I'm hooked on to where that starter pull-in coil connects to the solenoid output that would go to the starter. And I will just ground this to the case as well. So this is what I would be sitting at when the key's in the off position. Both my hold-in coil and my pull-in coil are getting grounded. One's grounded at the case, one's grounded through the starter motor, even though I'm not grounded through the starter motor. Push the button, it sucks it in. Now, if I held that for a while, it may get a little warm because I have a ground on that pull-in coil. So let's try it without the pull-in coil. Pushing the button, nothing happens. Well, what if I push it in first and then push the button? Well, it stays in till I release it. So the hold-in coil is the only one doing the work right now. So let's see what it looks like on the scope. I'm going to put this on 60 amp mode. I'm going to go around the lead that goes to the solenoid. Let's hook up the other ground cable and let's maximize this. Throw a trigger at 5 amps. Now I'm going to hold my finger over the plunger because I launched it out last time and had to reset some stuff in the starter. So how many amps do you think it's going to take to run the pull-in coil and the hold-in coil at the same time? And I think that we're actually going to see the movement of this plunger in here as well, very similar to like a pintle hump on an injector. I don't know for sure, but that's what I think. Almost 40 amps. Let me stop this capture. Maybe. Computer says no, I'm not going to stop. Oh no. What did it do? Did it lose it? We'll just take it again. Okay, so let's zoom in. We see that we're taking about 40 amps to engage. Now we see a huge pintle hump here. So if I measure down, once it fully engages, we see about 37 amps. But we see the movement in the waveform. We can see that the plunger is moving. If you had a vehicle that didn't start and you see like 40 amps and the plunger is not moving, there may be something mechanical in here that's binding up, causing that not to engage. But we're pulling 40 amps when we're running the pull-in and the hold-in coil at the same time. Now I'm going to reset the scope here. We're going to disconnect our ground for the pull-in coil, and I'm going to push the button. Now the plunger is not going to engage right away because it doesn't have enough strength to pull it in. So let's drop our cursor down, and we are only at 13.8 amps. So we are at 38 amps total. Did that other one stay on the screen? No, it didn't. So I'm going to do one more capture simulating what happens on a normal start cycle. I'm going to push the button. I'm going to let it engage. I'm going to unhook the pull-in coil. The solenoid will stay engaged, and then I'll release it. We'll stop the waveform capture. Now it's going to happen much faster, and you're not going to see the step in the amperage like this, because at that point the vehicle is going to start up and start cranking over. You might see it if you have an amp clamp around the solenoid connection. But let's move my cursor just a little bit here. So 36 amps with the hold-in and the pull-in coil engaged. We see a little glitch here as I was unhooking that cable. It was arcing a little bit. And then we dropped down to 13.8. So this tells me that my total amperage is 36.9. My pull-in coil, which I disconnected after the solenoid engaged, is pulling 23.1 amps, and my hold-in is only pulling 13.8. So the pull-in coil, I don't know if I said that right, but the pull-in coil is pulling double of what the hold-in coil is using. So what that showed us is that the combined amperage of the pull-in coil and the hold-in coil was 36.98 amps, so 37 amps. Once I released the pull-in coil, and we're only using the hold-in coil to keep that solenoid engaged, we dropped all the way down to 13.8. So that means that the pull-in coil is pulling 23 amps and our hold-in coil is only pulling 13. So it's using half as much amperage on the hold-in as it does on the pull-in, but it's even less than that since we're using drastically less than our total amperage for both of them combined. I just figured while I had this starter apart, I would share how the pull-in and the hold-in coils work. I hope that made sense. It was a lot of information and a lot of squiggly lines. If it didn't make sense, let me know, and I'll try to re-elaborate on a different video, probably with more advanced drawings than what I could scribble out real quick. So if you guys like the video, give it a thumbs up. If you want to see more videos like this, subscribe, click the bell. Thanks for watching, and I'll see you next time.